Again, for number 4, these two radical things are right next to each other. Just like when we have two things next to each other in other instances, it means we're just multiplying them. So we've really got square root of 18 vy to the power of 3 times 2 vy to the power of 2. And so it looks like I can simplify these a little bit before I multiply them. But I think in this instance, I'm just going to multiply them because I know that 18 times 2 is going to be 36. And then the square root of 36 is 6. So that will make it simpler on me. But if I wanted to, I could separate that 18 into a 9 times 2 and then take the 9 and make the 9 into a 3 and all that stuff. But just looking at this and kind of being strategic, I know 18 times 2 is 36. And I like 36 because it has a perfect square root. So we'll do that. 36 v times v is going to be v to the power of 2. Y to the power of 3 times y to the power of 2 is going to be y to the power of 5. Now we need to make sure that all these things are divisible or either have a perfect square root or are divisible by 2. And so we need to rewrite that y. So 36 times v squared times y to the 4th is what we want because that will divide by 2, and that leaves one more y. So this one is going to end up being, we're going to be able to take the square root of that, and that. We're going to be having square root of 36 is 6, square root of v squared is v, square root of y to the 4th is y squared, and all that remains inside the radical symbol is the y. Okay, that's it for number 4. Moving on to number 5. So for number 5, I don't think 10 has any factors that has a cubed root, and neither does 4. So I'm just going to go ahead and multiply these like we did the last one. We're going to get the cubed root of 40, x to the 11th. And so I need to think of factors of 40 that have a cubed root. So 8 comes to mind because 2 times 2 times 2 makes 8. Let's try that. Cubed root of 8 times 5. Then I need a number on the exponent for x that is going to be divisible by 3. That's going to be 9. Then I need 2 more x's to make the 11. We will be able to take the third root of that one and that one. The third root of 8 is 2. The third root of x to the 9th is x to the power of 3. Again, I'm going to use the dot for multiplication here because I don't want this third root number right next to my exponent of 3. It confuses me. And then I get a 5x to the power of 2 over there. And I do believe that that is as simplified as number 5 can get. Okay, I'll leave that there for a moment. We'll check number 6 and see how nasty it is, and I might make it in a new video. Number 6 doesn't look too bad. It's just the distributive property, but again, if you need to pause there, feel free. Number 6, distributive property. Square root of 5 times square root of 3. Square root of 5 times negative 8. So we will have, let's just write it out, square root of 5 times square root of 3. I prefer to put plus here all the time. Square root of 5 times negative 8. And so here we get square root of 15 plus a negative 8 square root of 5. If we clean our signs up, we get square root of 15 plus, minus 8 square root of 5. And I think that that's all we can do on that one. I'm going to verify that really quick, and I'll be right back. And it looks like that is all we can do on that one. So no real simplification of the radicals here. Not much we can do. But that's what that one's going to look like. I'll be back with another video for the last one, number 7.